Today we're going to begin Module 14, which is all about distance and area in the coordinate plane. Okay, so unfortunately I was not able to get the real world video and place it in the YouTube video because we can't access it unless you're logged in. I will include the link when I post this for you. However, you must be logged in to view it. So I think last time that I posted the real world video, I got a lot of feedback, everyone telling me, oh, I can't see it, it says it's not available. But if you log in, and then you click that link, it should work. If it doesn't bring you directly to it, what I would say is log in and then maybe put the link in the bar above and see if that works. If it still doesn't work, guys, all you have to do is go to Module 14 in your Go Math Online. I'm going to show you quickly. Let me just get it set up. Okay, so this is how my screen looks. It's a little different for you guys. But when you go to Student Resources, all you have to do is find your unit that we're in. So we're in Unit 6, Geometry, Module 14. Okay, and here it is, Real World Video, Module 14. Okay, I don't think that I can play it on here because of like copyright, etc. So you guys have to watch that on your own. And just to throw it out there, you can get the Math on the Spot lesson videos here. And if you ever have trouble downloading the worksheets that I'm using, they're usually in here also, as well as the reteach. Okay, so that's how you do that on here if you'd like to watch the real world video and you can't get it from the link that I posted. Okay, so for Module 14, we're going to begin with 14.1, distance in the coordinate plane. And then after that, so only one more lesson, polygons in the coordinate plane. Okay, so let's begin. This explore activity is kind of fun. I'm not going to do it with you guys, but if you would like to try it, it's a fun one, reflecting in the coordinate plane. If you have some graph paper at home, what you're going to do is you're going to draw the point, and then you're going to follow the directions where you're folding and use the reflection using light to draw the reflected point. I did this in class with the 6th grade last year, and it was pretty successful. So if you guys want to give it a shot, go ahead. I'd love to see pictures. Okay. All right, so let's get started finding distances in the coordinate plane. So what we're going to be doing is we're going to be talking about how we can find how far away 2 points are from each other in the coordinate plane. Now, once you get into like 10th grade geometry, there's going to be a whole formula for this when the points are not directly above or directly next to each other. So this is just kind of a sneak peek. And it's a little bit easier than what you're going to be dealing with in the future. But it's super important because this is the basis of what you're going to be doing when you get to that point in geometry. So make sure you pay close attention to this. So mine, without all the colors, is a little unclear. So I'm just going to darken it in. We're going to find distance between point A, which is here. This is A, and B, which is down here. Okay. Now, we're given the 2 points. A is 4,3 and B is 4, -2. Because they have the same x value, they are directly above and below each other. Okay, so what you're going to look for when you're finding distance is which one of these numbers is the same. Okay, so that means that the x value is the same, so that means that they're vertically in the same spot. This makes it easy on a graph. Just looking at it, we can figure out the distance between them because we can just count 1, 2, 3, 4, 5. Okay. However, in this lesson, what you're going to be taught is how to find that distance without even looking at the graph. So you're given these 2 points. We're going to imagine that we don't have this. So A is 4,3 and B is 4, -2. To figure out the distance between 2 points, what you do first is you identify which of the coordinates is the same, and then you ignore that. You're going to look at the 2 coordinates that are not the same. And what you're going to do is you're going to find the absolute value of each of them and add them together. Because remember that distance can't be negative. So the location of the B is -2, but the distance is positive 2. So we have to remember that we're dealing with only positive numbers here. So what you're going to do is you're going to take the two coordinates that are not equal, and you're going to take the absolute value of them. So it's going to be the absolute value of 3, and you're going to add that to the absolute value of negative 2. Because that's basically telling us how far away each one of these is from the x-axis. So the absolute value of 3 is 3, and the absolute value of 2 is negative 2, sorry, is 2. And that gives us our 5. Okay? And so while you can see on the graph, you can just count. This is the way to do it. Now for point C and for point D, slightly different. What you have to look at here is the fact that they're both in the same direction away from the y-axis here. So before, when we did this, we had A was on one side of the x-axis and B was on the other side, and so we added those two together. In this case, if we're looking at the distance from the y-axis, we're going to have to subtract. So you look at these, which one is the same? And of course we can count 1, 2, 3, 4. We know our answer is going to end up being 4. C is negative 1, negative 4. Oops, geez Louise. Oh my gosh, I'm so sorry. And D is negative 5, negative 4. So again, we're going to ignore the ones that are the same, and we're going to look at what's not the same. So in this case, instead of adding the absolute values together, we have to subtract them, okay? The reason why we added them before was because we were on opposite sides of the axis. If you're on the same side of the axis, you're going to subtract. So this is going to be the absolute value of the point for D, which is 5, minus the absolute value of the point for C. So that's going to be 5 minus 1, which is 4. Okay? So let's turn the page and take a look at what this looks like without a graph. All right, so here we have, we're going to find the distance between these 2 points. For number 3, you can see that you have the y values the same. Okay, so for the y values being the same, we're going to look at the x values and find the difference. What you can tell is that this x value is negative, this one's positive, so they must be on opposite sides of the axis, which means you're going to add them. So the absolute value of negative 4 plus the absolute value of 5 is going to be 4 plus 5, which is 9. Okay, and let's say units. If you need to take a second to sketch this out so you can see, oh, negative 4, 7, and 5, 7, okay, and you can see that they're on opposite sides of the axis, okay? But really the key is just to see if they're the same sign or not, pretty much. Okay, for number 4, you see the x value is the same and the y value is different. So now take a look, they're both negative. So they're gonna be on the same side of the axis. So let's just show that quickly. 0, negative 5, approximately 0, negative 10, you can see. Okay, so what you're gonna do is subtract here instead of add. So I'll take the absolute value of, I'm gonna do the bigger one first, absolute, and of course, I don't mean bigger, the absolute value will be bigger. The absolute value of negative 10 minus the absolute value of negative 5 will give me 10 minus 5, which is 5 units. Okay, when in doubt, if you are really not understanding when to add or subtract, you can always just sketch it and you'll be able to tell, okay? Let's see what's next. Solving distance problems. Oh yeah. Okay, so what we have here is a coordinate plane that represents a map, okay? Not that we're taking the state exam anymore at this point, but this used to be a very common type of a state exam question where they give you a coordinate plane that represents a map. Each one of these grid units represents 20 miles. So that means instead of going up by 1s, they're going up by 20. Okay, so if you want to take a second to fill it in, you can. You don't have to, because this one's solved for you, but either way, it's up to you. So a retail company has a warehouse at M, which is here, and that is negative 70 and 10. And then it also has one at point N, which is 50 and 10. So we want to figure out how long does it take a truck that drives 40 miles per hour to travel from M to N. So basically what we need to find is the distance. And once we know the distance, we have to figure out how long it's going to take if we're given that speed. Silly, but that's okay. All right, so what we can see is these are on opposite sides of the axis, right? And if we didn't have the graph, we'd be able to tell because this one is negative and this one's positive. So what we're going to do is we're going to take the two absolute values and we're going to add them. So negative 70 and positive 50, that's going to be 70 plus 50, and that's going to give us 120, good Lord, sorry. 120. Okay, so the two are 120 miles apart. So we need to figure out how long it's going to take the truck to get there. It drives 40 miles an hour. So think about it. It's 40 miles an hour, 120 miles to go. All you have to do is do 120 divided by 40. And I show it this way because you guys know I like to cross out my extra zeros, right? So it's going to be 12 divided by 4, which is 3 hours. Okay, not terrible, right? Okay, and let's see, your turn. A store is located at 50, negative 30. How long will it take a truck driving at 50 miles per hour to drive from warehouse N to this store? So let's go back to our graph and plot this point. 50, negative 30. 50 is going to be right by N, and then negative 30 is going to be in between negative 20 and negative 40. All right, this is P. 50, negative 30. Okay, so as you can see, they're on opposite sides of the axis, so we're going to be adding. Okay, let's find the distance between those two. It was 50, 10, and is 50, 10. Okay, so again, the x values are the same, ignore them. And now just take the absolute value of these two and add them together. 10 plus 30, it gives us 40 miles. Okay, and that's going to help us figure out how long it's going to take a truck driving 50 miles an hour to get to this warehouse. Okay, so what we're going to do is we're going to divide the 40 miles by 50 miles per hour. Okay, so again, you can cross out these zeros. And if you know 4/5 is equal to 0.8, find what that amount is by finding, this is 8/10 or 4/5. You can find that amount of the hour. If you leave it like this, it's fine, but we're trying to find this amount in minutes or hours, right? So you can either do 8/10 or 4/5 of an hour, which is 60 minutes, right? So this is 4 times 60, which is 240, divided by 5. And when you do this, you're going to find that it's 48. So that's 48 minutes. Okay? All right, guys, so that's everything. Yeah, the trickiest part is knowing whether you're going across the axis or not. But if you remember the little helpful hints I'm giving you, you'll be fine. If one is positive, one is negative, that means they're on opposite sides of the axis. If they have the same sign, then they're on the same side, so you would be subtracting. All right, guys, have fun with this.